Hi, my name is Abdul Siddhan Nazif. I am going to present our design and analysis of algorithm project titled called Social Media Hashtag Extraction using Navy String Matching. The aim of this project is to find all occurrence of a specific hashtags in a social media post or tweet. Hashtags plays an important role in identifying trends and organizing content on social media platforms. Let us understand this with a simple example. Here we have a tweet. Loving the weather today. Has sunny, has vacation, has sunny, can't wait for the weekend, has happy. Suppose we want to search for the hashtag has sunny. The algorithm scans the entire tweet and compares the hashtag with the text. It finds has sunny two times, once after today and again after hash vacation. Therefore, the output is hashtag hash sunny found two times in the tweet. This project helps in identifying popular hashtags and analyzing social media trends efficiently. Now, let us move on to the demonstration of our project and see how the algorithm extracts hashtags in a real time.
So I'm going to do the demonstration of our experiment or assignment. So as we can see, this is the algorithm. We're going to get the output. So as my friend told about the small concept of or idea of how the algorithm works. So this is the main text and this is the pattern text. So we can edit it if you need, or we can do anything if you want. Okay, to add a new text and do for that also. So basically the start execution button is used for starting simulation. So this here, it is used to run the animation which will show how the algorithm works more like in visual way. So when we start, so it is in very speed method. So as my friend told, first we'll check the character. If it is matching, it will be incremented, but if does not match, it will be just moving to the next character. So as you can see, it is started and here we'll get an increment. So as we saw, the pattern got incremented at the end. So when it got an matching a character, it got incremented to the next pattern character. Like this, it will go for till the end of the patterns. So in the end, let me just speed up. So in the end, we'll get an final output like here with two hashtags was the pattern we're going to find. So current status with including of the space bars, it was 55 characters. So I included a space bar. This is a space bar. So 52 characters, and it was showing a step-by-step execution log, so we can understand it more better. If someone is going to use this website, it will be in description. You can click and go through the website. It is completely free and nothing to worry about it. It has the all what we're going to explain in this video, all will be there in that. So in the end, we got an output of extraction output. So this is the place where we'll get the output what we want. So here the match position was 26 and 26th position, 43rd position, and the pattern was sunny, and the text search we did is love the weather today, hashtag sunny, hashtag vacation, hashtag sunny. So the total matches were 2 and extracted was 2 hashtags out of 3, and the position we compared 55 characters with including of the space bar. I mentioned it with including of the space bar, and the matches were around 13 and the mismatches were around 42. So this is a language output. As we can see, it is JS on output format. So as I use in JS code, we can if we do another Python language or any Visual VS code, we can get an output through output be like similar to like this, like found true and like this. So this is just a demonstration of how it will work visually, and it will be more easy to understand.
Okay. My friend has already explained the problem statement as well as code demonstration and code visualization. Let's go to the algorithm parts. See, this is the code of the Naive algorithm. Here So we have taken the variable n, which detects the length of the text, and m which carries the length of the pattern. So, and here is the for loops which runs along the text, and the reason here n minus m is it doesn't go behind the text. It will if the text ends, the loop will have to end. So how it will work is it will compare the first element of the text to the first element of the pattern. Whether the match will occur, it will increment for the second element, and it will check the second element of the pattern as it will follow. If a match doesn't occur, so the text will be incremented as it till where the match will occur. If there is no match, then it will return the value where the no match has occurred. So here if j is equals to m means the text, all the text are compared, and the loop will end, and matches to push into I, which gives the index where the pattern has occurred. For example, A B B B C, so it is the pattern where occurred at the index 5th element, so it will return the value 5th. So pattern has matched at the 5th index. Then time complexity. So here is 3 types of time complexity: best case, average case, and worst case time complexity. So best case time complexity will occur when the element doesn't match to the element in the pattern. For suppose if A is the first element of the text and P is the first element of the pattern, so there is no match, so it will directly move to the next element. So it is considered as the best case, and best case time complexity is order of n. So next is the average case time complexity. So average case, only a few partial comparison has occurred, then it is average case. For example, if the pattern is AABB, then our first element A is matched to the text, but next A is failed, then it is average case, which is denoted as order of n into m. Then the worst case time complexity. So worst case time complexity will occur where all the characters of the text and patterns are identical or match up to very last element before. For example, our text has A and our pattern has A B, so B is not matched with the text, so it is considered worst because of last element is not matched.
Here you can see the results and analysis. Here there are 55 words and occurrence found is 2. The mismatched words are 42. Here we simply know that what are the exact words like hashtag Sunny and where it is found and how many matched and mismatched words are there. So for a real world application, that is called like real world impacts. What is hashtag? There are some hashtags used for every program. Next, trending topics to discuss, like scanning the million words to find the popular hashtags. Similarly, sentiment and brand analytics, and content filtering and feeds, like inside post where we should put hashtag, everything like that. Next, in the conclusion, we are using a naive string matching algorithm, which is a conceptual foundation program. Here, as my friend explained, it step by step matches every words where it will find a green spot like hashtag Sunny, which was the exact given. Shows that in 50 or 49 words where we will get the matches, like there are 13 matches and 42 mismatches. Here it is at position 63 and position 43, which are the match positions. So there are many social networks which uses advanced pattern search algorithms like KMP, which increases the speed of the program. Next, RabbinCalc, which uses ASCII like for matching the speed and similar objects. It matches and speeds the program. Next, Boyens-Moore, it similarly checks from right to left and sees which letters are matching and which are not.
So to finally visualize the project, we observe how brute force steps are involved, which uses or which does find the letters character by character by comparing in the real time, and this explains our whole project.
So in the end of the session, as my friend all concluded this all will be in my description of the video, so we can see, anyone can access it. Here is the whole demonstration slides, and it is basically website. In website only we did everything. So we can get so what pattern we'll find, we can get that and result or copy of that to pressing this download text and copy results. So we can share it to the person if you want. Thank you.